Now that we know how to import audio into our projects, let's go ahead and see how we can get them to play in our scene. As stated previously, to hear audio in a scene, you need an audio listener, an audio clip, and an audio source to play that audio clip. Again, every scene by default has an audio listener which is attached to the camera. And again, a scene can have only one audio listener. As such, I don't need to add an audio listener right now because it's part of the main camera that's in my scene. What I'd like to do is I'd like to attach an audio source to this spinning top so that the player can hear a sound emitting from it. Adding an audio source is very simple, as it's just a component and is in the component menu. To add an audio source component, I'm going to click Add Component, Audio, Audio Source. The audio source component has a lot of settings that I can use to control exactly how my sound is going to play and how my sound will sound. The first and probably most important property is the audio clip. What sound will my audio source play? I'm going to look in my music folder, subfolder of the audio folder, and I'm going to grab the background music audio clip and click and drag it onto the audio clip property of my audio source component. Doing this, and just this, now has sound playing in my scene. To test this, I'm going to hit play. You'll notice that the sound plays the same volume no matter what distance the player is from that spinning top. This is due to some of the settings on the audio source that we're going to take a look at now. The next property to be aware of the audio source is the output property. If we just want a simple audio source playing to an audio listener with nothing in between, the output can be left at none. However, later we're going to create some audio mixers, and we're going to see how we can change the output to be one of the channels of the audio mixer for some more complex audio effects. We have a property for mute, which obviously simply mutes our sound. And then we have the ability to bypass effects, bypass listener effects, and bypass reverb zones. Effects are audio effects that can be placed on the same game object as this audio source. Those effects will change how the audio clip sounds in very interesting ways. We'll look more at audio effects in a later section. Listener effects are similar to audio effects in that they are components added to a game object. However, unlike our basic audio effects, listener effects are applied to the audio listener and change how that audio listener hears all sounds. If we don't want this audio source to be affected by any listener effects on the audio listener, we can turn those off. Finally, we have the ability to add reverb zones, which will add an amount of reverb to our audio to change how the environment sounds. For instance, we could add a lot of echo if our sounds were emanating inside a cave. As a bit of additional information, it's worth noting that even though we can bypass effects on the audio source component itself does not actually control the audio effects. They have their own settings on their own components. The next property to be aware of is the play on awake property. When checked, the audio source plays immediately when the game object starts up. Unchecked, the game object does not play sound until we tell it to through code. The next checkbox property we have is the loop property. When checked, the audio source will keep playing, starting an audio clip over and over again to keep looping it over and over again. This is very useful for things like background music, where we don't actually want it to stop, we just want it to start over once it finishes. The next few properties are sliders. The first of these properties is the priority. The priority determines how important this sound is for our game. A priority dragged all the way to the left is considered to be high priority. When a sound is high priority, it's less likely to be swapped or chopped up in case there are too many sounds playing. You'll need to remember that computers have only so many audio channels, and if we have a lot of complex sounds playing all at the same time, some of them might get cut off. Setting an audio source to high priority reduces the risk of that happening, and is generally reserved for things like the player's audio or background music. Inversely, a low priority states that this audio source is not very important and can be cut off if it needs to be. The next slider is the volume, which is a normalized value between 0 and 1. 0 meaning completely quiet, and 1 meaning 100% volume. Obviously, if we want to make an audio source quieter, we simply can drag this to the left. The pitch slider affects the pitch of a sound, while the stereo pan is useful for 2D audio. When we say 2D audio, we mean audio sources that play the same volume regardless of the distance from the audio listener to the audio source. In a moment, we'll investigate 3D audio, where an audio source plays louder or quieter depending on the distance from the audio listener to the audio source. 3D audio mimics real life in that sounds get quieter the further away you are. 2D audio, however, is very useful for things like menus or universal sound effects, where you always want the volume to be high regardless of a player's position. I'm going to go ahead and press play so we can see how volume, pitch, and stereo pan all work for 2D audio. We can hear the volume having an effect on the volume with which our audio source plays, the pitch slowing down or speeding up our audio source, and finally the stereo pan controlling which speaker our audio plays out of. If we want to control whether an audio source is 2D or 3D, we simply need to use the spatial blend slider. We can see the audio starts as a 2D clip, but if we drag it all the way to the right, it is now a 3D clip, and will change depending on how close or far away the audio listener is from the audio source. The last slider control we want to look at right now is the reverb zone mix, which basically controls how much of an effect the reverb zone has on this audio source. Now that we've turned our audio into a 3D audio source by moving the spatial blend property all the way to the right, we can expand the 3D sound settings. Inside the 3D sound settings, we have a lot of control over how this audio source will behave with 3D audio. The first setting is the Doppler level. The Doppler effect is effectively a shift in the frequency applied to a moving sound relative to the position of the listener. Meaning, as the listener is moving faster or slower around an audio source, you'll hear the frequency of that audio source pitch up or pitch down. A great real-world example of this is the difference in how a car sounds as it passes you on the road. The spread setting determines whether or not the audio source will be treated as 3D stereo or multi-channel sound in speaker space. Finally, we have the volume roll-off, which by default is set to logarithmic roll-off. We can see an example of this logarithmic roll-off in this chart, where we can see the line drop very sharply and then steady out. If we'd like, we could choose linear roll-off, which causes the volume to drop off at an even rate over distance, or we could create our own custom roll-off, which works just like any other animation curve. The minimum distance and the maximum distance is in world units. Since our world is not that big, if we wanted the effect to be more exaggerated, we could change it to be between 1 and, say, 25. As such, we would hear a much more significant drop-off in volume based on our distance from the audio source. With logarithmic roll-off, the volume of an audio source never completely turns all the way off or goes to zero. If we want to hear our audio fade completely away, we can change it back to our linear roll-off. Then we can see at 25 units, the volume will effectively become zero. We'll notice when I first press play that we don't hear our audio. You'll need to remember that the audio listener is not on the player, but the camera that's being drugged behind the player. As the camera gets closer to our spinning top, the volume gets louder. If at any point we want to see how close our audio listener gets to our audio source, we can again look at the graph under the 3D settings on the audio source component. The red vertical line indicates the distance the listener is from the audio source. In the next section, we're going to look at some interesting ways we can diagnose and test audio in our scene view.